Oh, hey, everybody, let's not take attendance today. I see a couple of people sending me their attendance records. I'm going to report back that everybody was here. I just don't want to deal with attendance. If you want to record this today, they're going to record. It's that easy. And the recording is when the lecture's finished, and you want to stop the recording. It usually goes into this 3 minutes of I don't know what they're doing. They're transcribing the video to MP3 or MP4 or something. You have to wait it out. Um, I guess they record the video in some kind of raw format, and then to make it viewable, uh, it does some piece of work at the end. Um, it's okay. It works. Okay, okay, got it, got it. Okay, so, well, let's start talking. Time is 10 o'clock and 2 minutes. So, oh, somebody remind me, last week, did I talk about the CPU and the hardware? Talk about the component parts, general purpose registers, SSE, FPU. I did do some of that. Okay. The previous, I just don't want to repeat myself. Oh, well, here we start up for today. This is the 27th. Uh, January. And we are CPSC 240. Yeah. Okay, first thing, um, your your program description doesn't have what to do with to submit your program. So it's been fixed. Download a new copy of assignment one and see the last page. Last page. Or it might be next to the last page. And there's instructions what to do to submit your program. Okay. And I'll mention some highlights right here is you may submit it more than once. Okay. So, however, I can't grade all those submissions. I grade the last one. The most recent one will be graded. It's graded. That that's to take care of the case where it's due on Friday, but you're done on Wednesday, and you turn it in, but then on Thursday you discover something you forgot to do right. So you want to go back and fix it and still turn it in. Yes, you can do that up to the due date. You can turn it in 6 times if you want. Uh, the most, the newest one will be graded. Will be graded. Okay. Um, there is a there is a grader who's working with me. And is a grader. And it's a guy, grader. He has to be anonymous. So I'm just going to refer to him as the computer science assembly grader. Um, so in practice, probably he will grade 75% of what you of your submissions. Yeah. And just so I keep in touch with what's going on, maybe 25% for me. Um, he wants to make some money, so I can't take away all of his work. Uh, I'll come back. I'll come back to standards of a good program in a moment. Let me then address. Would I write it down? Okay, so SI every semester starts in the second week. It's just that their ordinary schedule is to start in the second week. It begins this week. And it's today at 1 p.m. in room 102A. That's down the hall. We're in 104, so it's only a few steps away. And there's a total of 6 SI meetings to choose from throughout the week, but this is the first one on the first day of the week. I don't have the others written down, but here's a good starting place. Uh, yeah, I won't I won't advertise. I'm all in favor of SI meetings. They saved a lot of people's butts in the past, from repeating the course, and you should try and discover what you'll learn there. Okay, let's see. Oh, we'll have another announcement. I'll check the notes here. Oh, yes. Last week I didn't speak favorably of Tuffix, but I have a new outlook. Tuffix is okay for this course. If you're a transfer student, you probably never heard of Tuffix. But if you took your previous computer courses here, it's very probable you took a class where Tuffix was the place to do programming. It also works for assembly. Uh, if you already know how to use the Tuffix, there's nothing wrong with using it. Tuffix works for assembly programs.
Recording in progress.
Okay. In fact, when you submit your program, I never know where it came from. I don't know what computer you used, whether it was Tuffix or supercomputer. So I'm totally neutral in regard to where you build your programs. Tuffix is okay. Don't discard it from your computer if you had it last semester. And for new transfer students and everybody else, WSL is going to be with us for the next 100 years. It's a component of Microsoft. They're not going to let it go. WSL is for everyone else. If you don't know Tuffix, Tuffix is an operating system created here on this campus for use in computer classes on this campus. Okay, that's in case you're wondering. See, is there something else? I think we're caught up with that. Oh, there's one more is the criteria plural for winning points on assignments. You know, when at Christmas, when you give a kid a toy, like a 7-year-old a toy, uh, if it's a boy kid, he wants to rip the box open and play with the toy immediately, whatever it is. That means it works out of the box. As soon as it gets the box opens and this toy train will run around the floor or something. Okay. That's the standard for your programs. When I get it and I click on ./r.sh, it all runs just wonderfully. That's the standard that your program must run out of the box. Okay, so what if I get your program and I click on ./r.sh and it has 7 compiler errors in the driver and then 14 assembly errors in the file called triangle.asm. It ain't running out of the box, so it gets automatic 0. I'll put this here, compiler errors. Or assembler errors. Says 0. Don't even have to read the source code. Don't even have to check anything. I often wonder, why did someone send me that? Because if you didn't send anything, you still get a 0 in that space in the grade file. But no, you really get a 0. Okay, what if program starts up, asks for the user to input his or her name, and then it crashes. Mid run. That's easy. Just gets a 0. Don't have to read it, who did it. I'll just forget it. Yeah. Okay. Suppose program runs, and 2/3 of the way through it, thirds done, it freezes. Doesn't crash. Crash will give you a bad error message, segmentation fault or core dump or something. But program just freezes. It won't accept any more inputs. It won't terminate nicely. That's a score. 0. Okay. Then suppose freezing can happen anywhere. I just made up 2/3 of the way, but it could happen anywhere. We say it must terminate gracefully. Oh, so suppose that it runs to completion. Then the grader and I will have certain test sets to enter where we know the expected answer. So uh, this is talking about correctness of output. Correctness. Uh, so this is worth partial credit. If you're mathematically close to the right answer, you might slide by and have no points lost. But correctness could be way off too. It could give a negative value for the length of the side of a triangle, which is really a dumb answer. Correctness of output means, as the programmer developing this actually tested it and checked the math himself or herself. Correctness of output, this is partial points. Okay, suppose it runs and it produces correct output. Uh, there's no programmer name in the section at the top below the licensing agreement. There's the author information. There's no name in the file. What's the score? 0. Nice program, hours and hours of work, but this high school student doesn't put his name in there. Does this happen to college students? I get lots of them all the time. There's no name. They bumped the class size up to 40 for all computer science sections across the board this past weekend. There's lots of you. I ain't going to take the time to try to be a detective to figure out who sent this. It's marked for 0, and there's no second submission. After the due date is passed, there's no second submission. My grandmother's dying in the hospital. I have to sit there and read her poetry all this time. Take your laptop and do your homework there if necessary. There's no second submission after the due date. Do the companies, oops. If you're working for a software development company and you're building software on contract for a customer, which is another corporation, do you deliver it on time, or do you say, hey, teacher, can I have an extra 3 weeks to finish assignment 1 because I had to go to Las Vegas on 2 of the weekends? No. The contract will have a penalty clause, like $10,000 penalty for each day beyond the delivery date. Yeah. Here, the penalty is 0 points. You've got to put your name on it. Okay. And other things of lesser importance, don't forget GPL license, uh, the purpose, and facts about the program, such as how to compile it, and you can look at some sample programs I posted, and you can see 6 or 8 or 10 of these facts about the program that should be there. Why do we do that? I really don't care about those things, but it's practice for when you are in a professional position. You're working in a team. No software is built for the software developer. All software is built for somebody else. When you get promoted out of that team and someone takes your place, they have to understand what you've been working on, and you give them the facts, because that poor person should not have to read your source code to try and figure out what you're doing. This has to be there. We're in training to imitate what real life is when they're paying you the big bucks. They want a smooth transition when the next programmer comes and replaces you and you move on to another project. That information needs to be there. Okay. If it passes all those tests, you'll get a score on your, here's all this stuff. Has to pass all those tests. You'll then get a score on your assignment 1, and we hope it's close to 20. 20 is the max score. Okay, let me find, we're going to change subjects. Your document, it's been revised and you're going to download a new copy. That's the program specification. In your corporation, the customer, which is usually another entity, another company, comes with a set of requirements. I need software that will do all of this. And software engineers write, usually at the customer's site, write all those requirements into a specification. And then a representative of the customer meets a representative of your company, and they sign a contract. We pay X amount, $6 million on October 1st, if it's delivered on time and meets the specification document. Okay. I'm going to sometimes refer to that thing you download as the program specification. So that's where it comes from. It comes from here. You have a specification. You're going to build a program that does what it asks for, and submit it. And then your payment is not $20 million. It is 20 points. Okay, when your company starts working on a big specification like that, a requirements document, one of the things that happens is partition the solution. Solution, ION, solution into manageable pieces. Okay, so I gave you a partitioning because this program is so small. The specification document can be stated in one sentence. make a program that will accept the two sides of a triangle and the angle in between them and compute the remaining third side and show that number. Yeah. Well, here it is partitioned. So we're going to refer to this guy as the driver, and the driver at one point makes a call to triangle. In our realm, just for this classroom, this could be C or C++. This one does not know anything about the problem being solved. This one doesn't know that triangle is going to compute the length of a side. So this one has total ignorance. Uh, it doesn't know that there's triangle angles and sides being computed. What it does, it makes a happy welcome message. Then it makes a call. It calls triangle. It receives a number back. IDES, a number. Why move the camera there? Okay. And it displays that number, and it doesn't know what that number represents. If you notice how I wrote it up, that it just says I received this number and here it is, and I'll keep it for a while. It's totally ignorant of what's going on down here. That's rules of the game. Now, triangle has a lot of work to do. That's really where this course starts, is with triangle. So triangle, oh, you know what, I really, it has a prototype too. Prototype for triangle. It's going to return a float. D-O-U-B-L-E, sorry. Double triangle. And it receives no parameters passed to it when it's called, but it does return a double. Okay. The prototype should appear near the top of the driver. However, it needs additional help, and that's extern C double triangle. That expression needs to be in the driver near the top above. Let's see, I would put the includes first, and then this external expression comes next, and then comes main. So partitioning the solution, see, it's a good practice because it will scale upward to a huge program to be developed. The program to be developed could possibly be one driver. That's always one main, but below it there might be calls to 16 different functions, and those in turn call other functions. It could go on to 100 or more functions in separate files, and each file is supposed to represent some kind of unified activity. Within, well, let's just leave it like that. Most of the assignments here, I'm going to give you a partitioning and say, build it like this. Okay. And there'll be, in the worst case, 4 or 5 or 6 of these blocks representing files, each containing usually one function, but that doesn't, it's not restricted to one function. It's you could put 2 or 3 in one block, one of these. That's I'm not going to lecture on C++. That you're already experts at that. Okay, let's review what's going to happen in triangle. Okay, we want the standard form for an assembly function. And by the way, assembly will let you mix stuff up terribly. You can take the BSS segment and put it at the very bottom. You can split the text segment into two halves with some junk in the middle, but don't do it. To make uniformity, let's stay with the standard. The standard is, I'll try to be fast because I did some of this. There's a license at the top, license CE, LISCE, license. It's not license itself, it's license notification. There's author information below that. And below that, there's a purpose, P-U-R-P-O-S-E. And below that, there's technical facts. Which language it was written in, the date of last modification, facts about the development of program. Okay, none of that compiled. That's all comment stuff. Then comes a section. It has a header, declarations, like extern, print F, and the other externs, F gives. And you sometimes have to go back and fill in one when you discover that you need it later. Extern, string length. Okay, after that follows a segment. Data. This contains arrays, and strings are a special case of arrays. So prompt name. DB, please enter first and last names. Oh, 0. Okay. So I'm defining the array of chars in segment data. Segment. So in this order, I would separate with blanks. I recommend separating with blanks, 1 or 2 blank lines in here and under data. And under that comes segment GSS and username RESB 26. So I'll put an array for the user's name to be stored in there later. These are arrays without data, without initial data. Okay. Segment TEXT. First thing mandatory after that is the name of the function. Like such. The next thing is a section. We'll leave a blank line there, and then a block is a better word. Sections and segment are synonymous. They're the same thing. sections and you can actually replace the word segment with the word section, and it compiles, it assembles. Okay, those are predefined, but blocks, we create them. Block to backup GPRs. Yeah. The first two are mandatory. Push RBP and a move statement RBP. RSP. After that, you push all the general purpose registers, push all GPRs. It's tedious, but once you have it, or open one of my programs, just copy it and paste it over in your section, in your program. So that's the block that of backing up general purpose. So when we back them up, we have to restore them near the end of the program. There's a blank line there. So, okay, after this preliminary bookkeeping, we want to, you look at the dialogue and it says something like, welcome message, and please enter your first name, enter your first and last name. So we're going to have blocks here. Block. That's input of names. So it needs a string to be it's actually what we did here. Prompt name is please enter your first and last names. It's declared what the message is going to be. No, let's do this block. Do it so many times it becomes something you can see in your sleep. Move RAX0, move RDI. Let's be very formal. String form. That's fine. What was the name of that? Prompt for name. Paul. And so in doing this, I discover I need this one to be defined in the data segment. So I would, on a computer, I'd scroll backwards and insert that one under the segment data. I'm really crowded here, so I'm going to leave it on the side. String form. B quote percent S 0. Looks like that. Okay. So you could, in fact, I kind of recommend it. See, what you can do is you can program all those next 14 blocks of code in here, blah, 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 blah. Put an RET at the end and then test run it, and you get 17 compiler errors and 37 assembler errors, and it looks horrible, and you want to quit. Yeah. But a more gentle approach is let's close off the program right there and just test that one block and make sure it's working. Okay, so to close it off, we have to reverse, we have to have a block that restores general purpose registers. Restore GPRs and what what did I call it back here? The backup uses all those pushes. The restore uses pops. Okay, so pop R15, pop R14, and you keep on going all the way back to, in reverse order, pop RBP. Yeah. So you notice that in the backing up, pushing RBP was first. Now popping RBP is last, and RET. I guess we could put a blank line between those. Okay, that's a, and then stop, close, save the file, and save triangle. Not ASM. I would run it right there. So as you can deal with a small number of errors and not be overwhelmed with dozens of errors. But we'll clean this up by running it right now. So what you need is an r.sh file needed. I think you should download one that already exists, open it up, and change the internal file names in a few places, and you're good to go. Use and existing r.sh. Okay. See, I can't remember. Well, let's. Oh yeah. I don't know, what is that? It's r.sh. It should already be there. # slash a bin bash. For technical reasons, that's supposed to be the very first statement, and this is really, really dumb. And it's a comment, but yet this bash is Bash is the language that's going to read this. A program written in Bash language is going to read these commands. The # is a comment mark. But what is, there are other, okay, Bash is one shell. In life, there are 5 or 6 shells. C shell, for instance. You're supposed to put here the shell of the computer where this is going to run. That's what I mean. For us, it's always Bash. Okay. Then comes your name. If you use one of mine, you see my name there, take it out and put your own name there, and somehow relate it to the program that it's being used for. Program triangles. That doesn't say enough. Triangle length of side. See if I can do it by memory. The first important one is NASM. I think it has very few parameters. -F ELF -O triangle. Oh, that's a syntax there. There's no dot there.
You put your big up on.
Yeah. Let me start the sentence over again. I put a dot there and there's not supposed to be one. NASM -F O. On the same line, let's see, is there any
I think it's
Is it?
Just put up 64.
Oh.
64 bit.
Oh, that's one. Thank you. Yeah, there's a 64 there. Very, very nice. You remember that. There's another one that we don't use until late in the semester. It's hyphen L. I'm gonna triangle dot LIS and then triangle dot ASM. This one you can, with no harm, you can omit it. We'll actually use it late in this semester, but it was a different color. These two are a pair. You can't. You can move the pair together and make it last, and that's or the first. It doesn't matter, but you can't separate the pair and expect anything to work right. All right. So when you get it, there was something else earlier where triangle is. It was compiling some other program. Just take that other program's name out and put your name in those three places. And the next line down is to compile the driver. Do the same thing. It's already there. Oh, it's not very good, this thing. Just change the names of the files. I'm not red either. G plus plus hyphen C hyphen M64 hyphen. There's another little one I'm drawing a blank on. We'll go for a big one, standard. You know what? I keep spelling stuff wrong. Let's try again. Okay. G plus plus hyphen C hyphen M64 hyphen STD equals C plus plus 20 hyphen O jump. And I know I'm missing something, but we'll just go on. Okay. And then geometry dot CPP. Generally speaking, those can be placed in any order, provided you keep the pairs together. Right now, there's only one pair that I can see. So you switch them all around. It did, and it's okay. So here is, originally when you got this file, probably there's a different name, not geometry. Just take that name out and put the geometry name in there. And you have an r.sh file, which generically is just called a bash file. Okay. So you continue in this fashion all the way to the end. Continue. Eventually, we may have 5 files in the partitioning, and so there would be 5 compiling statements, some in C++ and some in a NASM. But you just do each of them one by one. You come to the linking statement, replace the O files in the old linking statement with your new file, new O files. Here's a new O file, and back here, there was a new O file right there. The little O on the left side stands for output. It says output to the file name that follows here. The little O on the file name doesn't have to be O. It could be XYZ. But O is there just as a reminder that this file is called an object file. This file is called an object file. And you know, that's actually really cool. When you're done compiling an assembly, you have a binary file, compiled code, and the system doesn't know which language it came from. There's no hint. There's nothing to say this came from assembly and point to this one. This one came from C++, and another one came from C language. They're all just code. There's not all the source file information is gone. So if they all came from languages that are unrecognizable, by the time it's here, it doesn't recognize where it came from. Then you put them all together. It's like building blocks. You just stack them together, and we need a program that stacks them. And generally, G++ is I want to say better. It does its job well. It's the more powerful of the three linkers we have at our disposal. So this is the best of the linkers. Because it recognizes a wider range of library files than the next two that I'm going to give you. Okay. That's, the other two is G, C, and D. Order of power, not order of correctness or anything else, but the G++ linker knows more about external functions than the other two. This is middle grade. This is this linker that is provided with the installation of the C language. And it works okay, but it doesn't know all the libraries functions that are available. It knows it's restricted to the ones that C language uses. And this one is very primitive. That comes for free when you install NASM. Comes with the NASM installation. I default to G++, unless, what if you're working in an environment where C++ is not installed? Well, then you have to resort to one of the lesser ones, and sometimes you have to. Yeah. So take the linking statement and that you see in the borrowed ro.sh file and replace all those O file names with your O file names, like geometry O and triangle O. You just remove those others and put your names in there, and then you got a linker working. And lastly is, did I do this in the past? Last week? The linker gives you a hyphen O, and then you give it the name of the file that's going to be the executable. The executable, you can make up any name for it, but let's call this one, what are we computing? We're computing the length of its side.
Did you push the paper in?
Yeah. Let's call it, you can Okay, I'll just call it side. Okay. In Windows, it would be side.exe. In Linux, it's traditional to call it out. Yeah. So the linker will, because of the O, it says the output from the linker, when it combines all the O files together, it will be combined into a single file, and you have to tell the linker what that file name is. Well, here's the place to put it. Side.out. You can make up anything you want. You can use your name there, Fred.out, if you want, but use something generally that relates to the application being solved. Okay. Now, as it turns out, because of the security system, it often turns out that this doesn't have execution permission. The permission is set to non-execute. And so it's a good idea to put in your bash file something to give it permission. It would look like this. Change mod u plus x side. That gives execution, U is for user. You are the person using this. The user receives execution permission on the file that's named blast. These three have to be in that order, by the way. And then you go ahead and execute it. Dot side out. There's a dot there. Is that readable? Dot slash side dot out will run the program. In fact, I don't know quite the details of it, but dot slash calls a program that's inside the operating system that's generically called the loader. That's a function that's part of the operating system. This says to the loader, execute, do your job, copy this from external storage, SSD drive, a spinning drive or flash drive or wherever it is. It says copy it into memory and load the first instruction into the ALU unit. That's what this one does. Copies SIDE.out to RAM. It's encoded. The first instruction to execute the ALU inside the CPU. Where again, I didn't say it. It's correct what I said. It's just not, the whole story is not there. There's a register named RIP. RIP, the loader is going to put into RIP the address of the first instruction to execute. And that kicks off execution. So an address in a 64-bit computer is 64 bits of integer. Yeah. So this thing usually looks ugly. Again, 3FF 8400208, something like that. Okay. That's the address after this is copied into memory from its permanent storage. It's copied into memory. And the first byte has an address that's copied into RIP. And RIP's name says I'm the instruction pointer. I point to the memory slot where the executable file is. And then this one is passed, not the pointer, but what it points to is passed over to the ALU unit. That's kind of hard to say, but you know, let me, my diagram's not right. Okay. That's an address out to memory. And in memory, there's an instruction that starts right there and it goes here. Okay. To kick things off, that one is copied into the ALU unit, and then it looks at the coding and says, oh, this is a move statement from RBX to RCX or whatever it is, and then it carries that out in electricity. It performs that work. We'll come back to get to this again many times in the future, but that's a special register. It's in the general purpose set. We usually don't change it during our programming because it's carrying this important role that after each instruction is executed, then this one indicates where the next instruction that will be sent here is. So in very fast motion, this is updating itself very quickly. And when this one completes a execution of an instruction, this one tells it, here, this is what you get next. And then it completes. Now, we're coming to, in the future lectures, we'll trace through these steps, how a program executes. Okay, but that's the end of the bash file. So the bash file goes from a special header, is going your information. So if it gets lost, I'll be able to put it back together with your other files, your info, and then NASM statements and G++ statements, if you have any of them, and then linking statements. There's only one linking statements, and then a permission statement, and then a call to loader statement, and then you can echo and say goodbye. Any questions about anything? Oh, I did. What about inside triangle parameter? Is it empty or should we pass double side A? Oh, I mean, no, you don't pass those. You don't pass the side A or the side B. No, the function called triangle gets those from the keyboard. They're not passed in from another function. They're read in from the keyboard. Likewise, the angle. All three of those numbers come from the keyboard. Okay, so you need, I better do that in a moment. That's a scanf issue. We're just coming up to 11 o'clock. I'll come back to that in a moment. You also push RAX. That's apparently in relation to the backup. No, you don't push RAX. There are three of them that you don't push. where I wrote here, push all the GPRs. Well, it's not quite all, except RAX, we leave it out. RIP, we leave it out. And isn't there one more? I can't think of it. I thought there was a third one. RBP. No. Okay. We'll come to it if it's necessary. Those two are intentionally left out of the backing up process. RAX, because it's a transport register, it's used to transport integers when the calling function, there's the prototype. I can't see it. I wrote the prototype here somewhere. Oh, here it is. Okay. How does triangle get that computed number back to geometry, back to the driver? Okay. There are two registers that are set aside for returning numbers. If it's float, that one register is XMM0. But if it's an integer, where this is, it's RAX. So RAX has this special role of carrying back to a caller a data value that's an integer type. You can't carry these, a different one. So that's part of the reason, that's the main reason why RAX is omitted. It's, where did I write that? I guess the place. Here. Right at the very end of the function, RAX has this other role to carry a value back to the caller program. And the caller program knows that things returned to it are found in RAX. Okay. So we don't back it up and restore it, or we would lose the value we're sending back. Okay. RIP is running the program. We don't want to back it up early, and that would really found. I just don't do it. I can. It's too sensitive information. You don't want to change that one. Let the system run. Uh, each cycle executing one instruction. Okay, now what was I supposed to say here? Okay, for the rest of the semester, I'm going to try to end at 11 or close to 11 and conduct an open office hour after that. Okay, so three values here: side A, side B, and angle.
Let's go on BSS.
Let me think. No, these are not arrays. BSS wants an array. They have to, you're going to have to designate your own choice of registers for these. For instance, in comments, you can say XMM10 is side A. In comments, XMM11 is side B. And one more. We could go up to 15, but I'll just keep them in sequence. 12 is angle. Okay, So it's the job of the block of code that reads a number to finally put it in its proper destination. Let's do one. Let's do angle. So input angle. Store it. XMM12. And again, I said it before, but now come individual instructions. You don't have to comment individual instructions. It would just make programming so tedious. Well, I'm looking for just a nice descriptive header on the whole block. All right, so let's think about this. Yeah, hard to believe. Move RAX, comma, 0. Now, you're going to tell me that doesn't make sense because I've said that RAX holds the number of XMM registers involved. Yes, the XMM register, by the way, I'm going to use scanf to input this. The XMM register doesn't come into play until scanf is all finished. So it's still a 0 here. Okay, so we need a format for the float number angle. Float. Yeah, okay. So we need a float form. You go on a computer, you scroll upward, and then you insert this under BSS segment, float, under dot data segment, form, DB, float percent, no. Scanf needs a pointer in the second parameter. The pointer points to memory location where this number is going to go. So we need a pointer. The easiest one to work with, because it's right at hand, is RSP. So I'm going to push. Actually, I can put any dumb number here you like. I'll just 25. Okay. Quad word is there to say it's 25 stored in 64 bits. We can't see that, but the push operation needs to know how many bits are we pushing. We're pushing a quad word of bits, and we're just throwing in this junk number 25 to fill up some of the space. Okay. Now, after that, RSP is pointing to that 25. But 25 has no meaning for us. So we're going to tell scanf, hey, you're going to put it where the 25 is. Go here. RSP points to 25. RSP is always at the top of the stack. We recently put a 25 at the top of the stack. And scanf doesn't recognize RSP, but it recognizes RSI as its second parameter. So now we're ready to have scanf do its work. Call. Okay. Up to this point, there's been no XMM registers, and so this is still valid. See, that says how many XMM registers will be involved during the call of this. It's none. Now the call is finished, but this float number is sitting on top of the stack. So we finish this off with move SD XM 12. So it copies the float number from the top of the stack over to the destination register that we always wanted. It was back here. The angle would be in XMM 12. And to me, that's the end of the block. It's task accomplished. In a block. And you put a blank line below this to sort of separate it from the next block. Okay. Scanf has that nature. It doesn't know XMM registers. It doesn't know anything about that, but it knows about memory. So it wants to put this in memory someplace. And you know what? I left out one little thing. Okay, I forgot. Scanf is at fault here. It wants to put this incoming number in memory rather than in XMM register. I argue that the easiest place for memory is the top of the stack. I create a top of the stack, give it a junk number, move the pointer to top of stack to the register that scanf understands. Scanf understands the primary 6. Here's the first of the 6, and this is the second of the 6. And we don't go any further on this example. So we better fix it now. Good programming. I ended the block too early. That junk number or that float number is still on top of the stack. We got to get it out of there. Then you're at the end of the block because we've restored the stack back to the state it was when this block started. We push something on there. We use that in storage. We're done with that storage, and now we deallocate it. RAX is commonly used for deallocating junk that you don't want anymore. That's another one of its roles. It's all the time. You want to reduce the size of the stack, you pop it 3 times and all into RAX. So now Hamid asked about, okay, the parameters, Hamid, you need 3 of these blocks. 1 for each one of those parameters. They all look very similar, but you need 1 for each of them. And then you'll have your numbers inside the triangle function.
Okay, thank you.
And we don't push RAX. Anybody have a question for me? We're going to stop here. But I'm here until noon to answer questions.
So did we have to make like when we call scanf here,
Yeah.
is that from like the library?
Yes, it is. Yeah, so on an earlier page, I should have that declared.
Just the include SDIO?
No. Let me show it with the word extern. Like here. Here's a list.
Okay.
So add to the list, scanf. So these declarations are all the things this program plans to call at one point or the other. And the linker looks at this list and says, aha, in addition to the O files this programmer has given me, I also have to go find these others that are in this extern list. It does a lot of good work for us.
So in this input angle block,
Yeah,
where would we call that prompts angle
uh,
like a
the prompt to input an angle, okay, yeah.
because we wrote it up with the
Yeah, it was earlier. Just to put it in context. Segment. Okay. Then there's the backup stuff.
I can't see it on
Oh, so I'm going more abstract, backing away from it, so we can get a view of where things are positioned. Backup GPRs. That's a long list of all these pushes. Okay. And then we want a block to, I think, make a greeting, but you have to look at the handout, make sure you block, make a greeting. And it says, welcome to triangle program.
something like that.
Greeting, ING. Okay. Then a block that says, enter your block that says enter your name. Enter. This is a prompt. PT. Then there's a block that actually gets the name. Block that uses scanf. No, it doesn't either. It uses fgets. Fgets to input name. Then there's a block that says enter your title. Prompt. Title. Then there's a block that actually inputs the title. Input title. Then there's a block that says enter side one. There's a prompt. Enter sides. I'm going to skip over that. And then there's a prompt that was enter side. Oh, you have to use for numbers. You have to use scanf.
Okay.
Not fgets.
Okay, so fgets is for strings.
Strings only.
Okay, okay, that helps.
And then we're almost down to your question is where's this thing going to appear? It's coming soon. Somewhere here there's a prompt for angle. And then finally, here's this block put in here. Input the angle with it's a number, so we have to use scanf. Input angle with scanning.
And then to call the prompts, we just whatever we just call whatever we named it in the
Yes,
data segment, right?
that's correct. And then you end up with call printf to output what you named in .data.
Cool.
Okay. Then somewhere the math takes over.
Yeah.
Okay. Let's assume we got all the sides and we got the angle, and then there's a block of math statements.
Yeah. The hard part, if you will.
Okay. So you're going to use let's see, the trig equation is the first side squared plus the second side squared minus 2 times the first times the second times the cosine of the angle.
Yes.
Okay, this is a big block, but there's no input output. We don't see anything happening. The machine does it. Math to compute Missing side.
This will use the pointers to the memory addresses, right? To find the values
Uh,
or the
no,
variables.
you're gonna use XMMs directly.
Okay,
The numbers are sitting in three of them. You'll need another XMM when you square side A. You'll
Gotcha.
need a XMM 13. Square side B, you need XMM 14.
Okay.
And so on. You have to do what the trig formula says. Sorry. Goes back up and restore G P R S, and then so the whole main program is this sequence of blocks. So each one doing a tiny fragment of the big picture. Block, 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 block. You come back to restore. These are a bunch of pops. Okay. But there's one missing thing is that third side has to get back to the caller. That's what this does. You know where the third side is. You left it someplace. Okay, so copy it into XMM0, like it shows here. And it will get back to the we'll get back to the caller in C++. And the C++ can now put that number there. Okay.
Successful output that result, right?
Yes. Yes. It receives one number back and outputs it.
Going over implementing, we said we put,
Yes.
yeah. We said we put book form under BSS, correct?
Oh, no, I want to correct that.
Yeah, because I was like, because we're defining, so I was like, why would that go under?
I spoke a mistake.
Thank you.
Sure.